So the next step in my build is to get some form of video output on this, and VGA is what I want to start with. And to do that, I've done a little bit of prep work here, and I have taken this board with this two-digit 7-segment display, and I trimmed it off. It was covering up this entire port, and I wanted access to this port, so I've done that. The port underneath it, I've also put in some right angle connectors just to get to some of those pins. These are all my global pins. Basically, there's 8 of them on the FPGA. I'm just exposing them through basically this location here. Really not doing anything with them yet, so it's okay that this is sitting on top of it. But then over here, I did want to access this port, and it was covered up, so I just sliced off this little design board that's plugged into there. I then also came in here and filled in 2 more of these ports. And just to do a real quick test on this, I did come over to this code on my system, and this is just my testing top-level module in Verilog. And in it, if I turn this back on, you might remember that I'm just simply counting up through these. I've put in a slower clock, a clock that will correspond to more of a VGA signal. Later, I'll put in the faster oscillator and deal with that. But right now, I just put in a 25.2 megahertz. So this is moving slower, but this just simply cycled through those bits. What I've also done, though, is added that test to these 2 ports so that I could unplug this and plug it in and just make sure, that those ports are fully working, and to make sure that I've got everything, soldered up correctly on the FPGA. And so this is one layout. It's just simply checking each of the bits. This one's doing the same thing. It's just checking 2 per side and then another 2 per side. So it's just a different layout, but both of these are doing the same thing. And that just let me validate real quickly that these ports are good to go. So I'll just maybe put this back to where it was. And actually, something like that. Okay, so that's the prep work I've done. So 25, actually a 25.2 megahertz clock. So it's a little off from what I should have, but it's close enough, I think, for now. I'll deal with that later. And I have these extra ports filled in, and I did fill in one more up here that I'm not going to use yet. So then with that, I had to figure out, okay, how am I going to actually leverage these ports? So my intention is to use 16 bits for color. So I'm going to do an RGB 565, so 5 red, 6 green, 5 blue. And that's 2 full ports that I need to do that, because I've got 8 bits in each of these ports going to the FPGA. So these 2 ports are going to provide me my color data. And then I'm going to grab a couple pins off of this header down here for my sync signals. So there's a vertical sync and a horizontal sync signal that have to be generated for VGA. But between those 2 signals and these 16 signals, I should be able to do 16-bit color at some point. Now, couple of resources that I'm using as I get into this. On my blog, I have this Lattice iCE40 FPGA journey post, but towards the bottom of it, I am up to this next up section, which is this VGA output. Now, a couple of resources that are pretty handy. Over here on NANDland, there is some information about he's basically taken his Go board and doing VGA output on it. So he's got a video that goes with that, which is great. Talks about the VGA signal, which I've done a bunch of VGA stuff in the past, so I'm comfortable with all of that. And then he gets down into some other top level code. For example, here's some if I keep going, there's Verilog. There's some Verilog top level code that I used some parts of that. In addition to that, he's posted, let me get back to this, some content over an EDA playground. Here he has some of these modules. So there's one for, really there's 3 of them here for generating all the appropriate signals for VGA. And then there's one that's for generating some test patterns. And he's got 7 test patterns, kind of in this code. And then he wrote a test bench for it. So those are a couple of really nice resources that I'm leveraging. And then I also have an older post I made on my blog, and this is about a video card that I was using previously that looks like this. And I've actually got that card sitting over here. Not sure if it'll quite fit in this frame. Yeah, it just will fit. So this is this video card. And really this video card supports 2 frames that I can swap. So there's one I can write to from the processor side of a system, and then there's one that is more on the output side that goes out the VGA connector, and I can programmatically swap. So I can be writing to one while it's outputting, and then I can swap and write to the other one and output. It's in an iCE form factor. You know, I've got my static RAM and everything else that goes with that. I'm using PSOCs in this case to generate address decode logic and all the timing stuff, which I now, instead of doing it with that, I want to replace all of this with this chip here. So that is a resource I've got here. And with that, I do have, if I go down schematics of what this card looks like, and I'll maybe flip over to that for a second. And when I look at this, you know, there's a lot to this card, but really all I'm going to care about is the very far right of this after these 74 273s. So there's all of this resistor setup basically that goes from digital to analog. And so I thought I would use that. And on my blog post, I have details for that and how to calculate these resistor values, thanks to Liquid Nyquist again over on Reddit. And he's also here on YouTube, but he helped me with some of this, just learning how to do some of this, which was very helpful back at that point. Now this card that I have is really a 5-volt card, and of course this FPGA is 3 volt. So I had to run through the calculations again, came up with the new values for the 3 different resistors on here. There's an R1, you can see I've got some of those here. There's a bunch of R2s, and then there's an R3 resistor. And so I had to recalculate those and found the closest thing I had on hand for those, and populated a new board. So I grabbed a blank PCB that looks like this, and really just populated all of the resistors for that digital to analog conversion, put in my DB15 VGA connector, and soldered in some connectors that'll plug into the headers on this FPGA board. And so essentially I'm grabbing, you know, each of these headers, of course, has 8 data signals, and then I'm putting 1 ground in between as far as what I'm actually connecting to the board here. So I'm grabbing the first 4 reds and then a ground, and then after that I'm grabbing the next red, and then I'll work my way into the greens, and then I'll have to jump to the other connector to finish out the greens and the blues. And again, I've got a ground in the middle of this set of wires. And then I have my horizontal and vertical sync signals coming in down here. So I just solder that on with a ground. And then I'm going to connect those into this board. Now, the actual connection then, oh, and one other note, the schematic for this board that I had pulled up did not have R3 in it. So those are manually added in. You'll see some of these 3 resistors that kind of look out of place. On this other card, I had put those on the back. Those were post PCB manufacturing that I had realized I wanted to add those R3s. But all of that is in here. Just that's the only part of this I'm using. Everything else I'm trying to replace essentially with the FPGA. And now I need to connect it up to my FPGA. So to do that, I've gone over into iCE40 2, and I will start out, let me get down here to the constraint file. So previously I had all these LED pins, all the 7 segment pins, all of that set up in here, but now I've come in here and I've set up really 16 signals that I'm calling VGA RGB. And again, that's this 565 setup. So 5 of them that are essentially reds, 6 that are greens, 5 that are blues, but I'll refer to it all as VGA RGB or O_VGA_RGB. So those 16 signals will give me my reds, greens, and blues. And then I've set up, and that again is, those pins are all coming off of these ports over here. And then I've got a couple other pins over here that are doing my sync. So the horizontal sync and the vertical sync, and I've got those set up right here. So that's this basically constraint file. So I'll get out of that and come back over here to my top level file. So with that, then I'll go ahead and connect these up. And these connectors have an extra, basically a column of pins. These are an 8x2. I only needed a 7x2. And then technically the two on the outside of the 7x2 are grounds, which I'm not using. I'm just pulling a ground from the middle. So I could have had a narrower connector, just I don't have any of those here, I guess. So I'm just using these slightly larger connectors, which fits just fine. Then down here, I need to get this connected, and I believe I used the bottom couple here. And so I have these pins, 17B and 17A. So it's an L17B and L18B that I'm connecting to for those. So I have something that's like that. And so that's the setup that I have at this point. And maybe other things I could quick double check. Let me do a couple things. So in this code right now, I have put in these temporary tests that basically what I was flipping up through this port, I was also writing to these other ports. That's what these two assign lines are doing. So I'm going to take those back out. I'll probably keep these around because that's kind of a handy way to test these things. And then I'm going to bring back in some code that's actually going to assign all of the appropriate VGA signals. So basically the way I have this code set up right now, way up top, I've set up my horizontal sync and vertical sync output plus my 16-bit RGB output. And then as I go down through this, there's some signals that are being used. There's some parameters that are being used to set all of this up for the VGA stuff. And you can go take a look at NANLand if you kind of want to see what he's doing, because I'm essentially just I'm leveraging that for the most part. He breaks all these signals out into separate names. I just put them all, and he's only using 9. I think he's using 3 bits per color, if I remember right. And I ended up doing a 565 instead of a 333. This is just me doing something a little bit different there. Again, referring to all of those pins under one name instead of separate names for everything. Then continuing on as I go through this, there's a call to generate the sync pulses. And so after I generate those sync pulses, get down here, and then there are some test patterns that get generated from a call to this test pattern gen test. And in his setup, he's using keyboard input, which I'll have to get to that later, kind of a serial input from a PC. But in my case, I'm just going to really go off of this other LED that's already doing counting. I already have a counter that counts from 0 to 255. I'm just grabbing some bits out of that, bits 4 down through 1. And I'm going to use that to pass in which pattern number I want to show on the output. So I'm going to basically set up 16 different patterns that I'm going to show on the output just to kind of get going. And then there's more of this VGA, some of these signals as far as where the porch is, and there's a call to get all that set up. And then I'm doing all the LED stuff I was doing before, and then I actually assign the appropriate values out to my individual colors. Now, something I am doing a little bit differently, being that he only had 3 bits, and I've got 5 bits. For now, I'm just simply saying take his highest, I think what it would be the highest intensity red, and apply that both to my top 2 red signals, and take the medium intensity and apply it to the next 2, and then the lowest red intensity and apply it to my lowest intensity for the reds. Again, he's going with a 3-bit, 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 and I'm going 5, 6, 5. This, of course, is going to give me the same, well, not my 16-bit color. This is really going to limit me to this 9-bit color for now, but I just want to make sure I can get something out. And if this works, then later I'll figure out how to generate the 565 instead of the 333 for the color. So I know I've got work to do there. This is my short term. If I set this highest, if this highest one is bit, the highest intensity red output is set, I set that on 2 of my reds. And if the medium is set, I set it on these 2. And if the low is set, I set it on this. And of course, full red would be all 3 of these turned on, which for me would turn on all 5 of these. So I'll get the full intensity red. I'm just missing a lot of in-between shades of red that at some point, hopefully this will be capable of doing. So I've got that there, and I obviously just made the changes with taking the test out and putting this back in. So I am going to have to reprogram the FPGA here shortly. Let me make sure that is saved. And then besides that, if I want to real quick pull up, this is this sync to counter. And again, this is pretty much as he had written it over on NAND Land. I'm using it as is for the most part, I think. And then same with the VSync porch. Really don't think I changed that much at all. I don't think I changed it at all. And same with the VSync pulses. So I'm just using those pretty much as is. And he's assuming a 25 megahertz clock, and I'm using a 25.2 because that's the closest thing I had. I tried a 24, it failed. 25.2 seems to be working. It maybe is a little bit fast, so maybe the timing is just slightly off. And I'll talk about one issue I'm seeing here once I get this fired up. But then I also have this test pattern, and I did modify the test pattern code a bit. So I came in here, and there's basically patterns that get generated. So the first pattern is all black, and then there's a pattern for all red, all green, all blue. And then there's a black and white checkerboard. There's a colored bars. And this is the type of stuff I need to just take time and learn, again, how to use Verilog to generate different video output, because that is not something I've done much of other than some old stuff on VHDL, on those Arctic 7s way back when. And that was, I think, some sample code I had used from Digilent. So I'll maybe go back and revisit some of that code to generate some test patterns and see what I can learn from that. But then there's a quick pattern here with a black with a white border, which I notice when I get into this, my top part of the border isn't white, so I got something a little off there. And then I'm just cycling through some different checkerboard pattern, or different color patterns, and then some different checkerboard patterns as I work through these all the way up through pattern 15, so 16 patterns total. And then basically when this gets called, you pass in a pattern number, and it's going to send out one of these patterns basically, or the appropriate pixels that match the pattern that I'm trying to display. So that, I think, is really everything I've got here. I showed the changes I made to the constraint file. I did, of course, update this file over here with the clock, and I changed it from 10 to 40 nanoseconds for the period because it's a 25 megahertz instead of a 100. And technically it's a 25.2, so this number probably isn't quite right, but it's close enough for now. Okay, with all of that, let me come down here and let me get this run. This runs Simplify Pro Synthesis. And once that finishes up, I will then hit Control A, which will do the rest. So the build did work on that fine. Control A will now do my place and route. I did, while it's doing that, on the bottom of this, I did put standoffs on the bottom too. So I have some higher standoffs up here, some lower standoffs, shorter standoffs here, so that when it's sitting here, it's angled just a little bit. Hopefully that'll help with the lights. And it will also keep all of this off of the metal that's sitting underneath it with this PCB, just so I don't accidentally short something out. And I want to kind of keep this straight, so I'm going to just real quickly put a little piece of two-way tape underneath a leg. Okay, that's just going to keep that straight for me. It was annoying me as it was turning a little bit. Okay, in the meantime, on my screen, it looks like the bitmap build finished, so I need to come down here and hook up my programmer So this really doesn't all fit on the screen very well, but again, I got my programmer. I have power off as I plug in my programmer, and then I can turn power on, and on my computer, jump over to this Diamond programmer and real quick program it. And so when it does that, again, you'll see the programming lights flashing, and at the end of this, hopefully on the computer, it'll show that everything was successful. Okay, so far so good. So I'm going to go ahead and turn that off. I'm going to pull off the programmer, get that out of the way. And then, of course, I need to get my VGA cable here. And with that, I'm going to flip to a different view. So this view on the left, I'm just showing the same thing, but then on the right is video capture that this VGA goes to. So this VGA output is going to basically a little HDMI, VGA to HDMI converter into an HDMI capture device that I have on my Workbench PC here. And then I'm going to go ahead and turn this on. Now, I do know that that capture device is a little slow at initially getting it shown, but let me turn it on and we'll see if we get output here. Now, I also have another monitor hooked up that you can't see. It's not in camera, a regular LCD that's basically split, and it's also showing output that I'm cycling through. Okay, so then as this is going, I have this little number showing down here, which I'm sure is really hard to see as it was in previous videos, even with a little bit of Mylar on top of it. This just isn't showing up great, but this is showing me which test number it is on. And so maybe what I could do temporarily is just turn off some of these lights, and maybe that's enough if I turn off one more here. Okay, so this is showing me, what test number it's on. So test number 7, 8, 9, 10, hex 10 is all white, and then a red checker, and then I go to a green checker and a blue checker, and then just some unusual shape checkers overlapping in another pattern. And then I go to all off, and then it's red, green, blue. And then there's a black and white checker and some colored bars. And that one's supposed to have borders all around it, but I noticed my capture device, something with the refresh isn't quite perfect, and I'm not maybe seeing it. It's just a couple of pixels around the edge, so maybe I'll have to make it bigger so it stands out more in the future. But anyways, that's just going through and doing some of this test output. And that all seems to be working fine as I go out of this connector and plug into my capture device. Now, one thing that's kind of interesting, there are two screens on here. There's the one with the vertical bars of different colors. There's 8 different vertical bars. That one, for some reason, on the LCD I have shows up blank. Not sure why. All these screens, like right now, you see show up on my LCD fine, but it's the bars one and the border one don't show up on my LCD. So likely it's just something I need to get my scope out and double check the exact frequency, and maybe that 200 or 0.2 megahertz is making a difference on this output when it comes to my LCD. I haven't done any digging into that at all, but I just know my computer here, our OBS with the capture device is capturing it fine, but then the LCD, physical LCD I have mirrored off of it or split off of it is missing 2 of those 16 tests for some reason. It doesn't show any output. So something for me to dig into later. But at this point, you can see this is doing the generation that it should be doing. And if I go back to my code again for a quick look at that, when I was down in these test patterns, that was the wrong one. You can kind of see what I've got back down here again. First is so set the red, green, and black to zeros. The next one is the all red, so set all the red pixels, basically turn all the reds on. This one's turn all the greens on, turn all the blues on. And then I've got this checkerboard. And then I've got this logic, and again, this is from NanLand, from his code, as far as this checkerboard or checker, and then this one down here that puts just a small border around the screen, a little 2-pixel just around the screen. And then after that, I added all the rest of these. So just instead of just red, green, blue, here's a green and blue, green and red, red and blue, a full white, and then some different checkers. Now, the way this is working, of course, he's just got it set up so that the only colors I think I can do with this test pattern routine is red, green, and blue, and a combination of. I can't choose to break that down into different intensities of blue. So I'll have to figure out, I'll have to look at the code and just see, okay, if I don't want to generate a test pattern that then comes back. So here he does have 3 different colors. So I have to just trace back, how are these 3 colors being set? It seemed like it was an all or nothing, but I might just not be deep enough into his code yet. But that's the stuff I get to play with and just kind of learn again how to do that. But I'm happy with where I'm at because, I do have, the FPGA generating the sync signals just fine, generating my color signals, which again for now is really just all red on, all green on, all blue on, or some combination thereof that. But I should be able to break those down into individual control as I get going here. So I think that's it. This is step 1. I've got some basic VGA output. Now I need to get more granular control of it, learn a whole bunch of Verilog on how to do some fun graphic stuff on the output. And then eventually, of course, I want to be able to get to where the video output could read off of this static RAM that's not populated yet. And maybe I'll flip lights back on here. But I want to get this static RAM populated, and if I can get that populated, then I'm wondering, could I use that for the video RAM and then programmatically populate that static RAM, probably within the VGA or the FPGA itself for now. But eventually, I want to maybe, whether it's sending in SPI into this or directly a parallel type of connection or some way from a larger system, let's say a 386 processor, to maybe write to this FPGA to that memory so that it can get output. And maybe none of that is going to work quite right, but that's the type of thing I'm working for. I do have some DRAM I could be using. I also have some dual port, a couple different styles of dual port RAM, but I do have one that is a small package that is parallel and serial out. And I know that's often used for video memory, so maybe that's something I could use at some point to have the output side of this read the serial out of that memory and then be able to write to it on the parallel side and put up text and characters, take keyboard input, things like that at some point. So more to come on the video side, a lot more work to do, but the basics, it seems like video output is working. And now I just need to learn how to do more with it.